Okay, so now we're recording. So like I said, we can do our, nope, not this one. We can do our elevation by doing this kind of color gradient. So that's one option. The other option that we can go over that's a little bit more detailed, but it just produces a slightly different result, where you can do like these kind of stepped contours essentially. That kind of just creates a little bit of a different result depending on what you're going for. So let's look at how you can find that height elevation information. So the first thing you're going to do is just simply take this, your starting surface here. You're going to go over to Mesh, and you're going to select the component Mesh BRep. So now you just have that same landform as a mesh instead of a surface. The mesh, you can just extract more information than a surface. So with this mesh, I'm now going to deconstruct it. So I'm going to go to my Mesh tab, choose Analysis, Deconstruct Mesh. And now you'll see there's a series of all sorts of different points on here. So I'm just going to turn that off because I don't really need to see it. So now that I have points that are covering this mesh or this landform, I can essentially look at all those different points and determine their Z value or their height, essentially. So this very top one is vertices, or another name for your points. So we are going to take those points and deconstruct them. So we're going to go over to Vector, Point, Deconstruct. So I'm going to drag this vertices into my points. And now I'll see that I have my Z values. So again, the height of those different points. So what I can do now is create a color gradient for those. So if I go over to parameters, choose my gradient, I'll see that there's a series of information it needs. It needs all in the lower part of it, the parameters, or in other words, all your Z values. So it needs to look at all that data. So I'm going to drag that into there. And then it also needs to know, okay, where's your highest point and where's your lowest, or your lowest point and then your highest point. So I'm going to go over to my Math tab, choose Domain, and say Bounds. I'm going to drag the Z into my bounds, and if I hover over this, you can see it has its highest value and its lowest value, so negative 27 feet, and then 251 is the highest. So that gives us our low and our high points, but you can see that this is reading as a domain. It's not reading as separate data lists that this needs. So we need to deconstruct that domain. So if I, again, go to Domain, Deconstruct Domain, so we're deconstructing it. We now have them separate. So here's the low point. Here's our high point. So I'm going to drag this into here, drag that one into there. So now we have a color range associated with those different points. It doesn't do anything yet because we haven't actually assigned those colors to anything. So just like how we deconstructed this mesh, now we have to reconstruct it. And by reconstructing it, allows you to associate those color values that we've just worked on. So I'm going to go back over to my Mesh tab. Now I'm going to do Construct Mesh. And we're going to just simply reconnect these. So my vertices to my vertices, my faces to my faces. And then you'll see it's also asking for colors. Let's turn this one off. So it's still just reading red because we have no colors associated to it. So this is where we're going to grab our gradient and drag that in there. And now you have a nice height field of your different elevations. Obviously, you can change your color gradient to whatever your graphic style that you choose for this, but pretty straightforward, right? Everyone understand the concept? Pretty easy. Okay, so like I said, that's another way that you can include in your deliverables is showing the actual height field, so we have a better idea of the overall elevation change of your landform, as well as showing your contours. Oops, not this one. And then the drainage lines. So there you go. Deliverable 1 complete. Pretty easy. Okay, so let's move on to the next section. Like I said, I already showed you and provided how to do the slope portion of it. So let's turn that off. Let's turn this one back on. You can keep the contours on there. It's kind of like one of those things. You're going to have a lot of different layers and information. You can choose what to have on or what not. If it's all relating to stormwater, maybe you want to show your drainage lines on every single one of them. I don't know. That's kind of up to you. Okay, so here's not necessarily a tricky part, but it's just takes some organization. Like I said, we could write the script to determine all these percentages of your slope classifications, but it's really pretty easy to do just by hovering over some of your components to find those values. So what you need to do for this part is determine how much of your, in this case, I guess the first thing is determine your soil type. That'll help you kind of figure out that matrix again. The next step is to then break it down to figure out, okay, how much is flat, how much is rolling, and how much is hilly. And that's, like I said, can all be found from your stormwater calculator. So what you need to do, so this first component here is all your forested area, your woodlands. So we're going to just start off with that one and then progress our way down. So in your calculator, the first way you can do it, there's a couple areas you can find the information. You could start it off after this minimum component. So you'll see that it has a total of 1,068 values that it's looking at and dividing into those different slope classification. You could also look at it over here. It's the same thing. So you could go to your dispatch component and find that. The dispatch might be the best area because that's where you get the other variables. So I'll just go ahead and write these ones down. So the first thing you see is that we have our woodlands. We have 1,068 values in this case. You're probably all going to have different ones, but that's fine. So we'll do, we'll first look at our woodlands. Then we'll look at our pasture or lawn. Then we'll look at our no cover. Then we'll classify it as, again, flat, rolling, hilly. Obviously, this isn't going to get recorded what I write on the whiteboard, but if you can just take a scrap of paper and write this kind of matrix, that'll help out. So, like I said, there's a total of 1,068 values for our woodland classification. So we can just write that number. So 1068 is our total values we're looking at. Then if I look on the other side of this, so this A value, I can see that it shows all those different values or a total of 3. So we know woodlands flat, 3. Pretty straightforward there. So then again, so we have that part. Now we have to look at the area that is those other classifications. So if we go down to our other dispatch component where we use our 10% pattern generator, we're using that smaller than. Again, it's still going to be that same top value of 1068, but now we can just look at the ones coming out of the rolling, or this is going to look like an A output. We can see list A says 10 values. So again, rolling 10 locally defined values. So we know this is 10. And then if I just move down, I see 1055. And you can see by just adding that up, 1055 plus 10 plus 3 equals 1068. So we have all our values accounted for. So now you just have to repeat that same process for these next ones. So I'll go down to now looking at my pasture area and go to that same area. Now we're looking at a total of, in this case, 727 values. All right, 727. I'll look at how many are considered flat. This output says 13. And again, I'll then go back down to my smaller, or that 10%. I'll look at rolling, 64, hilly, 650. And then we'll go down to our final part. We can see that there's 555. $26 of that is flat. And then for our rolling and hilly, 72 and 457. Okay, everybody follow that kind of logic so far? Again, whenever you're breaking down your surface types and their classifications by your slope percentage, so whenever you're using that component of like smaller than either 10% or 5%, that generates the pattern which is separating these. So look at the output of these dispatches. I've renamed these so they look kind of weird. And so if you can't remember which one to look for, it'll most likely look like this. So I'll just drag that into there and there. So if you didn't rename it, look for that dispatch component. It's going to have, again, the list, so that total value that you just have to look up once, but then you have the output. So one case is going to be 26, then this is 529, but that gets divided into those two classifications. So one way to always just remember to, or verify if your numbers are correct, just see if when you add all these up together that they equal that top number, right? Make sense?
Are those values for your model?
Yes. So you're all gonna have different ones. But like I said, the process is the same. You're gonna see what those total values are. Make sure when you count these up that they equal, right? Because we're just looking at the total number of those classifications in those three different categories, right? Everyone understand that part?
Repeat that. Yeah.
So like,
Not in my head, but yeah, I don't think
so you have, again, your three different surface types, and then you have each one of them classified in the three different slope categories. Okay?
Yes.
Cool. Okay, so now we have to actually just find the percentage of each one of those. So if I add up the total of these top values, I already did this, so I don't have to recalculate. That's just 2350 in this case. So there's a total of 2,350 little parcels of surface that we've evaluated in this script. You guys are going to have your own unique value. I can see that there are, and now I'm just gonna add these across. So I'm gonna add all my flats, so that equals 42. This is 146. And this is 2162. Again, if I add those all up, they should all equal the same value. Okay? And then it's just a simple division to figure out the actual slope or the percentage of each one of these classifications. 2350 divided by 42 is obviously a very small number. That's about 1.7%. This one is 6.3%. This one is 92%. So a lot of it's very hilly in this case. Not too much of a surprise. So everyone understand that logic of how you actually find the percentage? So divide the total number of surface areas by their different classifications. Simple arithmetic. Cool. Okay, so that's that part of our slope percentage. So what you should do for that, and I'll go over how to actually lay out that information on your 11 by 17s, but is that all that's we're asking for that deliverable? Any other things needed? Yay, nay? I'm trusting you guys. You can just say.
This is all for deliverable 2?
Yep.
Yeah, I think you got it.
Okay.
Yeah. So percentages, slope average, and then soil texture corresponding to volume.
Yeah. Yep. Cool. All right. So there's that. What's the next deliverable?
Surface conditions actually.
Okay. What do we need for that?
Proper vegetation graphics with 3 different types of, that stuff with them.
Sounds good to me. Okay. So we need to do that as part of it. Again, something I'm just going to add to this. It's very simple, so don't freak out. I just want to know the percentage of your different surface areas. So what percent of your model is classified as woodland, what percent is classified as pasture, and what percent is classified as woods. Luckily, that's even easier than what we just went over. Anybody think they can take a quick guess to figure that out?
You just collect the surface area of each one of those layers,
And then what?
and then you divide that into the total area of the site.
Yeah, exactly. So like I said, this one's pretty simple. If you were good enough in Rhino to just already organize them by their layer, I can just select the layer. So I'll select woods, right click, say select objects, then type area. I get up in this dialog box saying 391,408 square feet. So jot that down. So I'll see. I could probably just write it here. So 391,408.
409.
Is it 409 or?
Round up.
Yeah. Whatever. Fine. So I'm just going to do that for the other ones too. Pastures. Again, every time you select it, make sure to deselect, else it's going to add that. So make sure nothing's highlighted. Select objects. Area. Now I get 643.
526.
526. Man, I wish I had eyesight like that where I could read from where you are. No.
It's glasses, dude.
Okay, so now the last one. Select objects, area, 745016. And again, you're just going to divide each one of those values by the total surface area, which is, just by looking at that, it's about 1,779,951 square feet. I already had that written down.
Yeah.
Okay, so that's, again, how we get our percentages. Again, we'll go over how to show that. What was the other thing? Show proper representation? Yeah, so just because I have these divided into different surface types doesn't mean they actually look like what they are, right? It's all looking very flat. I need to make some attempt to have it read as actual forested area, as grasses, and then no plant cover can just stay as is. So you don't have to, again, get too complex with this. I just made a very simple little lollipop tree because, again, the way Rhino works, the more detail, the more it's going to lag. I just need something to say, yeah, I've got some trees in that area, right? So you can do that. You can download a 3D tree and populate your model and crash your computer, or you can take a much more simple approach by modeling one, by just giving it a little stub and then the canopy here. That's pretty easy if you just use your circle tool. I can say it's got a, I don't know, half a foot radius. Take that curve, extrude it about 10 feet. Let's move that over. And then I can draw a sphere on top of it. I'll just start off saying 15-foot radius. Drag that up till it's still intersecting, and then I can distort it a little. So there you go. So that's, then you can just take those two, use the Boolean union, and now you have one solid mass for your tree. Like I said, don't make it too complicated. So the next part is, how do you actually populate these areas? So do you think you should just take this tree and just manually make dozens and dozens of copies on your?
Nope.
No, probably not. This is where we can do a really quick and simple script for that. So I'm going to open up Grasshopper. So I'll just move over to the side here. I'm going to take my wooded area, select objects. Let's think I have some curves, so I don't want to do that. So I'll just select my forested areas, reference those. And so, kind of like what we did before, we're just going to populate this with a bunch of random points. So I'm going to go over to Vector, Grid, Populate Geometry. Now each one of those has 100 points randomly placed. That might be a little dense for now. Let's just reduce it for the sake of, again, our computer's compliance. So count, let's drag that up to 50. So that works. Okay, so now we have all the areas that we want to plant a tree on our forest. And what's good, this script can be applicable to a lot of things when you're designing. If you want to do quick massing of areas with trees. So I've got all those points. I need to now take this geometry. So I'm going to reference that as a brep. Okay. I'm going to now find the volume. That way I basically just have a point that's going to show up. It's probably being hidden right now. So it's right there. And what we're basically going to do is say, take this object, wherever this point is, and populate it to all these other points. Right now, if I were to just run this or add a couple more steps, it would literally place the middle of that canopy halfway through that. So we want this point to actually be at the stem or at the bottom of that trunk. So we're going to take that point, so this centroid, and project it down to a plane. So now we can see it's right there at the bottom. So I'm going to turn all this stuff off. And so the next step is to just find out essentially the movement from this point to all those other points to create a vector. So I'm going to go to vector, vector 2 point. So I'm looking at from this point, so our tree point, to all of these points. And let's go ahead and just flatten this. So you can see it's giving me 300 directions. So this point to all those different points. And now we get to use the move tool. So I'm going to go transform. Let's just type move. And here's the cool part. So it's asking for a geometry to move. So that's our tree, or this B rep that I've referenced. And then it's asking for a motion or a direction. That's what all this is. And just like that, bam, now I have all my trees. So pretty cool. Like I said, so you could actually, then you could start to kind of distort and give them a little more hierarchy, but pretty simple. And then if you're like, maybe I want that to be a little more dense, I can always go back, change it to 75. There you go, now it's more done. So now, like I said, it's very applicable to a lot of things. So if you ever want to, let's say you make your best tree ever in Rhino and now you want to populate it all over your design, you can run this pretty simple script right here to do that. Sound cool?
Yeah.
Yeah. Okay, so then let's just go ahead and bake this onto my tree object layer. And there you go. Now you actually have all those baked on. I wonder what that looks like rendered. That's kind of weird. Not exactly the best proportion. Look like, yeah, it's weird. Anyways, okay, so that's how you do trees. Any idea of how to do grass for your pastures? Pretty similar, right? So it's even easier. It's like grass, it's literally just going to be some kind of vertical curve. So I'm going to, again, just take those surfaces, select multiple surfaces, reference those, turn that off. Do the same thing. I'm going to go to vector, populate geometry. And this I'm probably going to want to be really dense. I might want to join these ones real quick. So I'm just going to copy and place, join. Now I'm just going to say set one surface. That way they're all, oops. Probably didn't like that. I can do it. Darn. Anyway, so let's just do it this way still. That's the issue when you start to slice it. I could always slice those ones up more so it does it, but anyways, you'll get the idea from this. So I'm going to just populate this with a crap ton of more points. So I'm just going to say, let's try 500 for now. It's probably still going to not look all that dense, except in that area. But all you're going to do is take those points. You can do curve, and then you can just do line SDL. So this is just taking a point. Let's go ahead and flatten it. Direction, it's already going in the Z direction. So you can see they're just very small. Length, 1 feet. I mean, just for the sake of visibility, we can make them a little bit taller. Let's see what it looks like in that more dense area. So that's at least looks dense. So you could just leave it like this and just bake all these curves. They aren't really going to get rendered out. So you can do a couple different things. You can do surface. You can do a extrude to point. You could just extrude a curve from it. I mean, it's not going to look like grass, like certain, but let's do flatten. Then I'm also just gonna, because it needs a radius or a base curve and then a point. So I'm just gonna create a circle at each one of those points. That's probably a little bit too much. So I could do like 0.5. That could be our base. And then it's looking for the point. So I'll look at these curves, use a point on curve, say move up to there. Now you have a lot of little grasses or triangles, however you want to. Looks very like old school Nintendo kind of graphics, but you get the point, right? The other way, what's another way you can represent pasture grass?
Texture on the surface.
Texture on the surface, right? So maybe you just go to Photoshop and apply a grass material. So that's another way. I would say that's probably going to work best. The trees, I think that looks pretty good and it's pretty easy to do that. The grass, you could either do it in Rhino or in Photoshop or something, because I'm not buying that. So let's just delete that. Okay. What else is needed for, is that it? To represent the land, the different types?
The acreage of each vegetation type.
So we already did that by just essentially calculating the square feet. You could do acreage. So again, that's just going to be these values divided by how many feet? So if we want to know the square footage in acreage.
Oh, you divide by 43,506?
Nope.
Close.
You got the last two numbers out of order.
560?
560, yeah. 506, huh? That's a weird conversion. So yeah, 43,560. We'll convert those to acreage. Okay, what else do we need?
We're going off volume X on.
Right, so what's needed for that?
Runoff analysis.
What are the components for that?
Drainage areas labeled.
So you don't need drainage areas, but it's all in one.
extends in volume.
Right, so we need to find the volume of our runoff. That's, again, what we kind of left off last week that we can try and cover again today. So again, from your calculator, I've got my peak flow rate of 24.6 cubic feet per second. How do I convert that to volume for a 1 hour long storm event?
That's 24 what, inches per second?
Cubic feet per second. So I need to know,
You gotta convert,
so I need
1 hour
runoff.
to seconds. And then divide it, or multiply that.
Yes.
by whatever the
So again, this is giving us cubic feet per second. So we have volume and time to give us flow rate. Now we just need volume. We know it's a 24-hour rain event, so that gives us our time variable. So we need to convert 24 hours. Is it 24 hours or is it 1 hour storm event? I can't remember. What's the assignment say? Is it 1 hour?
We're trying to keep it simple.
Yeah, because I think it's 1 IPH.
1 hour long, 2 years long.
Right, okay, so 1 hour long. So we need to convert 1 hour into seconds, which is
3,600.
3,600. So we're going to take this value, multiply by 3,600. And that will then give us our volume, which is around close to 90,000 cubic feet of runoff. And as we found out last week, that doesn't appear to be a whole lot of runoff volume. Because again, this is supposed to mimic a natural landscape, which is roughly, has a roughly 3% runoff rate. It would be interesting. You could like do a very kind of interesting comparison. What would happen if you just completely draped this landform in concrete? That's a good way to think like, okay, like this is what a undeveloped site looks like in terms of its runoff generation. You could easily just determine how much runoff would be generated if I were to calculate, if I were to change all the coefficients to concrete or a 1.0 just to see like, oh, maybe I want to know what this would look like if it was all concrete. So you could just change all these values to be 1 instead of these decimal values just to do a comparison. That's something that I'll leave up to you. You can also determine if it's a 1 inch rain event, if it's a 2 inch, 6 inch, those kind of things. So like I said before, it's at this point where you want to determine your runoff volume. Did anybody explore options to show that? So how would you want to represent runoff volume?
Cylinder.
What?
Cylinder.
Cylinder?
Yeah, rather than a sphere. Cylinder is more realistic into that. That's what you tension things.
Maybe.
Or some sort of polygon extrude.
Okay. So this could be interesting. You could start to create something that shows that comparison of like what is, because again, if we just see 90,000 cubic feet of runoff, what does that mean? Everyone in studio should have an answer for that.
Oh, 90,000 cubic feet.
Yeah, what's that mean?
That means that we need to show what it actually is. It's like,
Yeah, right. It's a very relative term. Is that a lot? Is that a little? That's where you have to, again, make that comparison to give it some validity to that volume. So that's what I'm saying. So you could say, okay, I'm going to take that runoff volume. I'm just going to manually input that. So 88,583 I can do multiple things. I could look at it for that. I can even take that rate. So if I want to determine for a larger storm event, I can go to my rate. So let's call this our peak flow rate. And I can multiply that value by a series of different rain events. So I can do 1.0 less than 6.0. So again, this isn't going to change anything. But then I could say, okay, I want to know what happens if this is a 3-inch rain event. So I'll drag that up to 3. And now I'll see that my volume is 265,749. And then maybe I'll just do one more because it's always good to have 3 values. So now for a 6-inch rain event, I have 531, 499. All right, so this is where you can start to make comparisons of what that runoff event is. Another thing, like I said, you could change your coefficient values. So if these were all to jump up to 1, if you were to say, if I were to cap this site with concrete or a coefficient value of 1, I'm not going to do that because we're just running out of time. But if you were to take that approach and you were to just change all these coefficient values to that, that would also give you a different runoff volume. So you could say, if this was a completely developed site of concrete and buildings, it would produce this runoff volume. So we get a comparison of what does a abstracted natural looking landscape generates versus what a developed landscape does. That's another valuable comparison that you can make. Like I said, this way is pretty easy. That way I can just make that comparison as well. You can go even further and say, what does 1 inch look like on undeveloped versus developed? What does 3 inches look like on undeveloped versus developed? So you can even kind of cross multiply those to get an even more comprehensive. That's again how you maybe want to try and get an A, is making that correlation. It's not that hard, it's just data crunching. Okay, what else is next? Yeah, so this I'll give you, this is kind of your freelance piece. You can turn on everything, so you can show all the different land cover types, the slope percentage, the drainage lines, just to give us kind of a comprehensive look of what your model looks like. You can bring it into Photoshop and render it out. You can have a lot of kind of free control over what that composition looks like. But we want to see what this looks like because all those steps leading up to this, we've looked at it in very kind of singular layers. We've looked at it for just a drainage aspect. We've looked at it for its slope aspect. We've looked at it for its surface types. Now we want to know, what does that all look like together? What does that mean together? So like I said, I want you guys to have your own kind of take on that. Does that make sense? Okay. So in these last couple minutes, we're just going to look at how do we represent each one of those pages real quick. Where's my tableau? Okay, so again, it requires you to do these on 11 by 17s. So I'm gonna just show a couple on how this, like especially the ones where we're talking about the slope portion and the land cover type. So rendered, let's just do it looking like this for now. So I'm just going to do, let's make sure. So I'm just going to render this real quick. Oops, why is it doing that? Oh, it's probably because of my safe frame. So let's just render this one real quick. Or actually, I mean, let's just do it like this. Because what's good, like, you can with some of it, but a lot of the colors you create in Rhine or in Grasshopper aren't going to get baked onto Rhino. So you might want to go this route of going view, capture to file. And I'm just going to put these on the desktop for now. So this could be land cover axon. Now I'm just going to turn those off real quick. Then I'm also going to show my slope analysis. Maybe again show contours or the drainage lines at least. Again, go to view, capture to file, slope axon. So again, I'll just go over to file, place. Let's do the slope axon one first, since that's probably the slightly more complicated one, not really. But. Okay, so how do we represent those percentages? We got 1.7%, 6.3, 92.
We need a color scale.
We need a color scale, okay. What else? What do these slope percentages even mean? What do you mean type?
Density of the surface.
Density, yeah. So again, we could go the traditional route of saying this is our slope analysis, but again, we're looking at the slope percentages for what purposes?
To say how much of each type of slope we have, flat, rolling, hill.
No. The flow of the water, it's all revolves around our stormwater runoff volume, right? So you can use slope percentages for all sorts of different analysis. We're doing it for stormwater management. So we need to specify or be clear that this is a slope analysis for runoff calculators. So it would be good to say, so we have our slope. Let's make this a little bigger. Or we could even do rational method, slope analysis. So we have flatland, which is I think I just happen to know off the top of my head is roughly 0.10 coefficient. We have at least 4. So let's do one more thing. So you have to classify what type of soil you're using, right? So this one I think is sandy loam. So the coefficient for a flat sandy loam is 0.10. So whatever you've chosen as your soil type, refer to those lecture notes to figure out what that coefficient value is. We have what else? Rolling, which I believe is a 0. Is it 3? Maybe. 2.5. And then we lastly have our hilly is 0. I think it's 30 coefficient. So maybe I just give it some space. Oops. Now let's, yeah. And then we can make our little legend here. Use our eyedropper tool. I guess the flat line is kind of white. I promise we'll make it on time. Not that you guys are really concerned. We got our dark blue, our rolling, and then lastly we got our hilly, which is this tone. So just get within the ballpark. I don't expect you to have the perfect color values. So like I said, now we have to give those percentages. Luckily in Illustrator, we can make charts. So I'm going to do a pie chart for now. Just going to make it fairly large. So I have, let's start with the largest one. So 92, 6.3, 1.7. Have you all made charts in Illustrator before? Is this alien or not? Okay. I mean, it's pretty easy. I just have to hit that check mark. Here's my chart. Obviously, we don't want it to look like that. How should it look like?
You should have your colors on your coat.
Yeah, let's use those same colors, right? So we can't just simply like separate each one like that. So first thing, I'm just going to get rid of the stroke because that's overrated. So I'm going to go, if you want, like this shouldn't change, but I'm always kind of paranoid of losing information. So that way I can always edit that data. But in this case, I'm going to go to object, expand. It's going to lose all its kind of charting information. I think, let's try one more time. Object, expand. I think I have to ungroup it first. So object, ungroup, this is where it says, so doing this, you lose all that information, blah, blah, blah. So now I can actually ungroup it all and then do, okay, so this one is this value, this one's that, and this one is here. Yeah, maybe you keep the stroke for that one. Maybe, and then again, this hierarchy and that kind of stuff we want to make sure is all relevant. So maybe I just scale this one from the center, hold Alt Shift to kind of keep it proportionate. And I can shift that over and say, hilly, 92%. I know you guys are all becoming masters at annotation and stuff, so I trust that you guys will know how to do this so it looks pretty cool. Again, everything you've learned, you should apply in your next class. So do something like that with the chart, obviously. Do the same thing with this so it doesn't look crude. So I think we'll just do this one for now. Obviously, I didn't specify all the details of what goes into each one, but just be smart about it. Make sure you can easily understand what is trying to be portrayed. And then maybe this, yeah, maybe you have to play around with this because it is, the way I did it's in a very kind of long version. So maybe maybe I'll do kind of a full extent of it all. I'm fine with that, but just kind of organize it the best you can. So it's kind of a pain, but just oh, that doesn't look so bad. So yeah, just make it read as kind of a very comprehensive page instead of just image, text, tell that story, like I always say. Any questions so far? Like obviously do the same thing where you can do, like you could do something really cool with, that's too late, no more time left. So like for doing your land cover type, you could, instead of it looking like water or whatever, maybe it looks like you put some tree silhouettes to represent woodland or grass to look like grassland. Make those kind of choices. Good, any other questions? All right.